operations here. To add or subtract radical expressions, the radicand, remind me what a radicand is? The number underneath the square root, good job, must be alike, just like monomial terms. And I used these as examples yesterday, and you guys grasped it a little bit better. You guys know off the top of your head, 4a plus 2a would be 6a. They both have an a, so I get to combine those coefficients just like they tell us to. Well, that's exactly how radicals are. If the radicands, the numbers underneath their square root sign, are the same, which in this case they are, we can perform the indicated operation. So this would be 6 times the square root of 5. Don't change the radicand. It's just like an x. It doesn't change. See if we even have to do this example. Go down here. 2 square root 3 minus 9 square root 3. Negative 7 square root of 3. Okay? Simplify each expression. 5 square root 2 plus 7 square root 2 minus 6 square root 2. 6? Yeah, 6 square root 2. They all have square root 2. 5 and 7 I can't do to save my life. So I went 5 and negative 6 is negative 1. And 7 would be 6 square root 2. Let's go down. 10 square root 7 plus 5 square root 11 plus 4 square root 7 minus 6 square root 11. Okay, group your, it's just like when we would group our x's, group our common, what do we call those things? Like terms. Okay, anything with a square root 7 can be combined together. Anything with a square root 11 can be combined together. So say it to me again, Morgan. Thoughts? Ooh, 14 square root 7 minus 1 square root 11. True or false? True. As long as you have 14 positive and 1 negative. Absolutely. Technically, no. If you mean like if you just had it like this. Yeah, technically you could just have that. Yep. Okay. Try the other two on your own on the right. (15 square root 3 minus 14 square root 5 plus 6 square root 5 minus 11 square root 3. Thoughts? Could you have negative 8 square root 5 plus 4 square root 3? Yes. Good job, Chloe. 6 square root 11 plus 2 square root 11 minus 9 square root 11. Negative. You're right. Just checking, make sure you were right. I thought it was negative 2. It's cool. It's cool. What can be hard about this? Subtraction is hard, Miles. You and I are on the same page. No matter what Gian says, it's okay. All right? No matter what Gian says over there. Here's what's the hard part. Not all radical expressions have like radicands. Simplifying expressions may make it possible to have them so we can add or subtract. This is what we did on Monday. Simplifying the expressions, the factor trees, breaking them down. So your number one step is, if they don't have the same radicand, is to go like, okay, how can I break these down? So we're going to make some factor trees. How can I break down 18? 9 and 2. 9 breaks down as 3, 3, 2. Okay? Now here's the deal. What number's already out front? Don't lose him. Okay? Who's going to join him? The 3. What are you going to do with this other one? He's still in jail underneath that square root. So 2 square root 18 really turns into 6 square root 2. Good job. Now we keep going. How are you breaking down 32? 18 and 2 is not 32, but 8 and 4. 8 is 4 and 2. 4 is 2 and 2, and I bring that 2, and I bring down these 2's. So I'm going to put a plus sign so I don't lose it. What number was already out there? 2. Who's going to join him?
2 other 2s.
2 other 2's. Good work. And then we still have the square root of 2, yes?
Why would 2 other 2's join it?
Because there's 2 sets of 2.
No, what?
You have 2, 4, 5 2's.
There's no-
Alright, so you circle
Did you bring your 4 down?
two.
Stop. Did you
No,
bring
I
this?
did 2 times 2, but like, I'm so confused.
'Cause
I
this-
actually got 5 2's.
Yep.
Yeah.
But there's a 2 already out front from
Oh,
way up above, and we just put 2 more 2's with it.
okay.
Okay? So I have 6 square root 2 plus 8 square root 2. Okay? Now I have 72.
36 2.
7, 9, and 8.
It's probably a little more simple, yeah.
6 and 6. Oh, I was gonna say 9 and 8. but
3
7.
2.
Now we got these in a weird order, right? 2 and... Do you have any number out front?
No.
No. Okay, so I need a 2 and a 3, and underneath the square root a 2. So really I wind up with 6 square root 2. Not done, don't quit. A lot of work to get it wrong. Yep, so you end up with 20 square root of 2. Okay, go to the right. Square root of 24 minus the square root of 54 plus the square root of 96 on your own. See what you get. So when I rebroke those down or simplified, I got 2 square root of 6 minus 3 square root of 6 plus 4 square root of 6. Okay? Thatcher asked me a good question right when you guys were starting. He said, you know, I have this 2 and 3 that don't have a partner. They both go under that square root, correct? And that is yes. If they don't have buddies, you multiply them back together and go under your square root. So your final answer should actually be 3 square root of 6. Anybody else? See the one on the left.
By ourselves.
I don't know. You pick. You want to do it together or you want to do it by yourself? Oh, geez.
Together.
All right. All right. No, yes, you can. I believe in you.
What's 245 divided by 5?
Well, how many times does 5 go into 24?
0.
5 4 times, right? And how many left over? 4, so then you'd have the number 45. How many times does 5 go into 45?
9.
9. So your number would be 5 and
29.
49.
49, I mean.
49.
I cannot do that.
Yes, you are fine. You were like one of the first ones done in the fifth. Fine.
Break down 5 into 3 and 2.
Yeah, that's not going to work out well for you, is it?
No.
What do we end up with?
I ended up with
4 square at 5?
I had 18 square at 5. I had 4 to square at 5.
I have 4 to square root of 5.
Do you want to do that last one?
No.
I just want to go
Oh, yeah, I remember yesterday when you guys were like, this is so good. No, put it up, put it up, put it up, put it up.
I want to go to my house. Can I go to 8A?
I'm good. Thank you for checking. Thank you for checking.
Can I go to 8A?
All right, grab a piece of paper. Don't visit. Get this done. Get this done. Get this done. Get this done.